Recording in progress.
This is the Chapter 5 and 6 exam review for college algebra. Problem number 1. Determine whether the given ordered pair is a solution of the system. To be able to determine if that ordered pair is a solution to the system, we're going to substitute that ordered pair into each equation and see if we get a true statement. So we're going to substitute x equals 1 and y equals -2 into both equations. So let's put it in the first one. Y equals 3x minus 5. So we have y is -2, x is 1. That is true. Now we're going to put it in the second equation. 5x plus 6y is equal to -7. So put 1 in for x, -2 in for y, and that is also a true statement. 5 minus 12 is equal to -7. So yes, it is a solution. Problem 2, solve the system by the method of your choice. I would probably use addition. That's my favorite method. So I am going to take that first equation and move the y over to the left-hand side by subtracting it. So now on the left-hand side of that equation, I have 3x minus y. And on the right-hand side, y minus y is 0. 0 minus 4 is -4. So now my two equations are 3x minus y is equal to -4, and 3x minus y is equal to 6. Oh, well, that can't happen. You can't have the expression 3x minus y equal -4 at the same time that expression equals 6. That's not going to happen. Now, if you wanted to go ahead and try to solve this by addition, you might multiply that top equation by -1 and get -3x plus y, and then plus 4 on the right-hand side. And when you add the two equations together, you get 0 is equal to 10. That is not true. So what we conclude is that this system doesn't have a solution. Its solution is the set that is empty. And again, just looking at the two equations, once I moved the y to the left-hand side in the first equation, it's obvious to me that the algebraic expression 3x minus y cannot equal -4 and 6 at the same time. All right, problem number 3. They give us a graph so that we can see what this looks like. The figure shows the graphs of the cost and revenue functions of a company that manufactures and sells small radios. Use the formula below to find R of 200 minus C of 200. Describe what it means for the company. Okay, I'm going to blow this up momentarily. You can do this in MyLab Math. You can take your graph and pop it out and blow it up so that you can look at it. All right, what you're finding is R of 200 minus C of 200. So you're finding the revenue minus the cost. And here's 200 right here. Now, I'm going to have to use the formula because the graph is just going to give me an approximation. But the revenue is below the cost. So if I take revenue and I subtract cost, I'm going to get a negative value. The value of the revenue here is approximately $10,000. The value of the cost here is approximately $20,000. So I'm $10,000 approximately in the hole. So revenue minus cost is going to be approximately -$10,000. Now I'm going to use the formulas, the definition of the functions, to find the exact value. But I do know revenue is below cost. So I am losing money. My profit is negative. All right, so I got that figured out. So now let's go evaluate these two functions. So I'm going to evaluate the revenue at 200. So I'm going to take my handy dandy calculator out and I'm going to multiply 48 times 200 and get the revenue. $9,600. Now we're going to evaluate the cost at 200. So we have 15,000 plus 26 times 200. Six times 200, 20,200. All right, so this is exactly what I saw on the graph, that the revenue is approximately 10,000 and the cost was approximately 20,000. I only could get an approximation from the graph. This is an exact value. So the revenue at 200 minus the cost at 200 is 9,600 minus 20,200. And I get minus 10,600. So minus 10,600. So what is this company doing? The company is losing money. So you've got two choices here for losing money. We've got C and we've got D. So which one is it? The company is losing money because cost is greater than revenue. That is correct. From the graph, you can see that the cost function is higher than the revenue function. So we're losing money because cost is more than revenue. All right, problem 4. Determine if this ordered triple 6 negative 2 2 is a solution of the system. So let's substitute this into each equation. We have x is 6, y is negative 2, and z is 2. So let's do it in the first equation. So we have 6 plus z is equal to 6. So we have 6 minus 2 plus 2. Is that 6? Yes, it is. That is true. Let's put it in the second equation. X minus 2y minus c is equal to 8. So we have 6 minus 2 times minus 2 minus 2. Is that equal to 8? So we have 6 plus 4 minus 2 is equal to 8. That is true. And let's put it in the last equation. So 2x minus y minus 2z is equal to 10. So we have 2 times 6 minus a minus 2 minus 2 times 2. Is that equal to 10? We have 12 plus 2 minus 4. And yes, that is equal to 10. That is true. So yes, this ordered triple is a solution. Solve the system if there's no solution, or if there are infinitely many solutions and the system's equations are dependent, so state. All right, I'm going to go ahead and solve this using addition. We are going to learn, of course, how to solve this using Gauss-Jordan elimination. So if you chose on an exam to use Gauss-Jordan instead of solving it by addition, just let me know that you did that. And be sure that you write your augmented matrix down so that I can see what you've inputted into your calculator. Now, I think the easiest thing to do is going to be to multiply this equation by 3 and add it to that one, and the same. Multiply the last equation by 3 and add it to the first one. And that way I'm going to eliminate z. So I'm going to multiply that second equation by 3. When I do that, I'm going to get 3x plus 9y minus z is equal to 0. And then I'm going to add that to the top equation. And the top equation is 3x minus 6y plus 3z is equal to 24. And I lost a 3 somewhere, didn't I? Right there. It got lost. All right, so now let's add those together. So I have 6x plus 3y is equal to 24. So there's my first equation in x and y. So now I'm going to multiply that third equation by 3. Make sure I do it right this time. 3 times 6 is 18 minus 3y minus 3z is equal to 21. And we're going to add that to the top equation. So I end up with 21x minus 9y is equal to 45. Okay, so I'm going to multiply this equation here by 3, and I'm going to add it to that equation. 21x minus 9y is equal to 45. So I'm going to multiply that by 3, so I get 18x plus 9y is equal to 24 times 3 is 72. I'm going to add that up. I get 39x is equal to 117. Divide both sides by 39, and I get x is 3. All right, so now I have x. Let's back substitute and find y. I'm going to back substitute into this equation. The 6x plus 3y is equal to 24 to find y. So I have 6 times 3 plus 3 times y is 24. 18 plus 3y is 24. Subtract the 18 from both sides. I get 3y is equal to 6, and y would be equal to 2. So I got x is 3, y is 2. And then I'm going to back substitute, and I would probably do the first equation just because the coefficient in front of the z is positive. It's up to you, whatever equation you want to use. So I'm going to use that top one. So I have 3 times 3, x is 3, minus 6 times 2, y is 2, plus 3z is equal to 24. And I get 9 minus 12 plus 3 times z is 24. Negative 3 plus 3z is 24. Add the 3 to both sides. 3z is 27. And I lost my z there. There we go. And z would be 9. So I get z is 9. Now I'm going to do a quick check to make sure those work. I'm going to plug it into the top equation. 3 times 3 is 9. Minus 12. 9 minus 12 is minus 3. Minus 3 plus 27 is 24. So it works in the first equation. In the second equation, I have 3 plus 6 is 9. 9 minus 9 is 0. So it works in the second equation. In the third equation, I have 6 times 3 is 18. 18 minus 2 is 16. 16 minus 9 is 7. So there is a solution. It's x is equal to 3, y is equal to 2, and z is equal to 9. All right, we have a couple of nonlinear equations to solve here, nonlinear systems. Problem 6, solve the system by addition, and that really is the best way to go about this. You've got a hyperbola and an ellipse, and if you recall from class, a hyperbola is shaped like this. This one's probably shaped like this. I'm not sure what it's shaped like. And you have an ellipse, and my eraser came on. So you can intersect at 4 different places with an ellipse and a hyperbola. So I expect to get 4 solutions. Okay, so I'm going to multiply the second equation by 5. And then I'm going to add it to that top equation, and that'll eliminate the y squared. So I have 10x squared plus 5y squared is equal to 55. Erase that stray dot there. And that 55, that doesn't look like a 5. Let's get this all nice and neat here. Okay, make sure I did that right. 10x squared plus 5y squared, there we go, is 55. Now I'm going to add that to the second equation. X squared minus 5y is equal to negative 44. And so I get 11x squared is equal to 11. Divide by 11. So x squared is equal to 1. So if x squared is equal to 1, x is equal to plus or minus 1. So x is plus or minus 1. So now we're going to back substitute to find y. So I'm going to substitute 1 in, find y, and then substituting negative 1 in is going to give me the exact same two y's. So I'm just going to plug in x is equal to 1. And I'm going to do that in that second equation because that just looks way easier to solve for y. So I have 2x squared plus y squared is equal to 11. I'm going to plug in x is 1. And I get 2 plus y squared is equal to 11. So subtract the 2 from both sides, and I get y squared is equal to 9. And then if y squared is equal to 9, then y is equal to plus or minus 3. So what are my ordered pairs? I got 4 of them. So when x is 1, y can be 3, or y can be negative 3. Now, if I plug in negative 1 for x, if I plug in negative 1 for x, I'm going to get the same two y's, because if I plug in negative 1 for x, when I square it, it's going to become positive 1. So I'm going to get two ordered pairs where x is negative 1 and y is 3 and y is negative 3. So we have negative 1, 3, and negative 1, negative 3. So those are the 4 ordered pair solutions that I would type into that field right there. So we have 1, 3, 1, negative 3, and you do type them in as ordered pairs separated by commas. And then we have negative 1, 3, and negative 1, negative 3. All right, problem 7. Solve using the method of your choice. I would probably use substitution. In one way works better than the other. What works better is to substitute. I can't remember now. We'll just try one and see what it works. Let's solve this equation. Let's solve it for x. So I'm going to subtract y from both sides. I think it's the other one. Let's try the other one. I'm not liking that. Let's solve it for y. So let's subtract x. No, that's the other one. And you like me just trying something. And I'm looking at the equation. I'm trying to figure out what I want to do here. Let's solve for x. That'll be better. If I'm wrong, I'm wrong. I'm wrong, I'm wrong. So x is 21 minus y. It doesn't matter. Both of them are going to work. One is just easier than the other. All right, and I should mention before I get too much farther, this is a circle and a line. A circle and a line can only intersect at two places. So you're going to have two ordered paired solutions. Okay, so now we're going to back substitute. We're going to substitute what we got for x into this equation here. So we're going to take 21 minus y. We're going to square it. Okay, and then I need to FOIL that 21 minus y squared. So I'm going to take 21 and I'm going to square it. And that is 441. And then I'm going to multiply the y and the 21 together, and then multiply that result by 2, because I'm squaring the binomial, and that's going to be minus 42y. And then I have a plus y squared. So that is 21 minus y squared. Then I've got a plus 2y squared, and that's equal to 441. And this is the better way to go to solve this for x, because what happens is that the 441 will subtract off. Let me go ahead and combine like terms here, though. So I have 441 minus 42y plus 3y squared is equal to 441. I have some static electricity building up on my iPad. It's making my pen look weird. Okay. Equals 441. So now when I subtract 441 from both sides to put this in standard form, I end up with a really easy binomial to factor. It factors by just factoring out a common factor because there is no constant term. So it doesn't factor to a binomial times a binomial. It factors to a monomial times a binomial. And I think the common factor is going to be 3y. So let's factor that out. If I factor 3y from minus 42, I have minus 14, is that correct? 42 divided by 3 is 14. And then I have plus y. I'm going to check that real quick to make sure that that is the correct factorization. 3 times negative 14 is negative 14 times y. Then I have 3y times y is 3y squared. So I set the 3y equal to 0, and I set the minus 14 plus y equal to 0. Divide by 3, y is 0. Add 14 to both sides, y is 14. So the two values from y in my two ordered pairs is 0 and 14. Now we're going to plug that back into this right here, the 21 minus y, and we're going to get x is 21 when y is 0, and x is 7 when y is 14. So 7 and 14. So 21 and 0 and 7 and 14. And I would check that. 21 is 21. It works in the second equation. How about the top equation? I would have to take my calculator out and do that. I leave that to you. Well, I probably should do that. So we're going to take 21 squared. 21 squared is 441, so it does work in the top equation. Now let's try the second ordered pair. I have 7, 14. 7 plus 14 is 21. It works in the second equation. So I need to square the 7, which is 49. And I need to add 2 times 14 squared. And I get 441. So those are the ordered pair solutions to this system of equations. And again, I kind of fumbled around at the beginning there. One way is better than the other. Solving for x works out a little bit easier than solving for y. So that's what I recommend you do for that particular problem, solve for x. Okay, problem number 8, graph the following. We have y is greater than 7x minus 4. So I'm going to graph this because it's already solved. It's in slope-intercept form. That's what I'm going to use to graph this. So I'm going to take my graphing tool in MyLab Math, and I'm going to graph the y-intercept at -4. And then I'm going to use the slope to find a second point. All right, so the slope is 7. So I'm going to go up 7 and to the right 1. 1, 2, 3, 4, 5, 6, 7. So I'm going to end up at 3 in the y direction, and I'm going to go to the right 1. So I'm going to end up at 3, 1, right there. I'm going to graph this using a dashed line. So in MyLab Math, when I graph the line, make sure that that is dashed. And it's dashed because it's y is greater than, not y is greater than or equal to. So the line is not included in the solution. So you want to be sure and graph that as a dashed line. So dashed line. And then I'm going to use a test point to determine what half plane I shade. Do I shade to the left of that line, or do I shade to the right? So I'm going to test 0, 0. It's the easiest point to test. Is 0 greater than 7 times 0 minus 4? Yes, 0 is greater than -4. So I'm going to shade the side that contains the point 0, 0. That would be over here to the left. Oh, got a system of equations. I have 3x plus 6y is less than or equal to 6. And 3x plus y is also less than or equal to 6. So I'm going to graph these using intercepts. Since we're in this quasi-standard form there, general form. Okay, so the x-intercept for that first line is 2. If I solve the equation, 3x is equal to 6. The y-intercept is 1. If I solve the equation, 6y is equal to 1. I'm going to graph that as a solid line. If my eraser doesn't turn on and erase what I just did. So 2 and 1, there we go. Then I'm going to graph the second line. I have 3x is equal to 6, so x is 2. So again, the x-intercept is 2. And then we have y is equal to 6. So we're going to graph that line. Use your imagination that it's perfectly straight. Okay, then we need to determine what part of this plane do I shade. I actually have 4 sections. These 2 lines are separating this coordinate plane into 4 sections here. Which one is the solution set of this system of inequalities? So I'm going to test 0, 0 in both inequalities. So I'm going to test it in the first. So I have 0 plus 0, is that less than or equal to 6? And the answer is yes. So I'm going to use my shade tool just to demonstrate what this is going to look like. So this is going to be here. So shade that in purple. So that's the solution to the first inequality. And the solution to the second inequality, let's see if 0, 0 works. Well, I have 0 again. 0 plus 0 is less than 6. 0 plus 0 is less than 6. That is true. So if you look at that second line, let's shade that in a different color so we can see where the 2 intersect. Let's use green. So that would be over here. The 2 planes that contain 0, 0. So where did those 2 overlap? Well, they overlap in that region 3, where both of those areas are shaded. It's where the shaded regions intersect. So it's going to be this, the shaded in dark purple maybe. It's going to be this region over here, region 3. Okay, problem 10. Graph the system. Now I've got a vertical and a horizontal line here, so that helps quite a bit. So I have 3x plus y is less than or equal to 6. Oh my goodness gracious, isn't that the same one I just did? Luck of the draw here. So I have x is 2 and y is 6. And we're going to graph that as a solid line. And then we have x is -6, and that's going to be a solid line. And then we have y is 4. That's also going to be a solid line. Okay, so where do all of these regions intersect? Well, for the first inequality, if I shaded that, that is over here. And then greater than -6, x is greater than -6, that would be over here. And y is less than 4, that would be over here. So where do those regions intersect? They intersect right in here. So that's what I would shade. Problem 11. Write the augmented matrix for the system of linear equations. So on this problem, in the next problem, I just need to put in the matrices. I don't need to solve for x, y, and z. I just need to put the augmented matrices in. All right, so to put an augmented matrix in, I just ignore the variables and put in the coefficients. So for that first row, I would have 2, 1, 6, and 3. For the second row, I'd have 8, -2, -1, and 9. In the third row, I'm going to have a 1, a -2, a -6, and a -3. And then I always check by columns. So I go down the X column, 2, 8, 1, check. I go down the Y column, 1, -2, -2, check. I go down the Z column, 6, -1, -6, good. And then the constants 3, 9, -3. I highly recommend on your paper that you turn into me that you write the augmented matrix down on a piece of paper also, so that I can see any errors that you made. If you make a sign error, for example, on that third row, if you put +6 into -6, I could see that. And I recommend that for every problem that you create an augmented matrix for. Okay, so the next problem, we've got lots of zeros. Let's go ahead and put this in. The first row, I'd have a 1, a -1, an 8, and a 4. The second row, the coefficient on the x is 0 because there is no x. So 0, 1, -16, and -8. And then the third row is going to be 0, 0 because x, there's no x there. There's no y there. Z is 1 and 4. So I'm going to check that real quick. 1, 0, 0, check. -1, 1, 0, check. 8, -16, 1, okay. 4, -8, 4. So I am good to go. All right, let's finally solve a system using an augmented matrix. It tells you to use Gaussian elimination. I would use Gauss-Jordan because that'll just give you the answer. And you certainly on your calculator can choose to do Gaussian with row echelon form, excuse me, or Gauss-Jordan using reduced row echelon form. So I'm going to use Gauss-Jordan. So I'm going to write my augmented matrix, and I am going to write it on my piece of paper so that my instructor can see what I actually inputted into my calculator. So what's my augmented matrix? So I have 4, 4, 16, 12, 4, 3, 12, 9, 4, 6, 33, 9. Okay, I'm going to do a quick check. 4, 4, 4, 4, 3, 6, 16, 12, 33, 12, 9, 9. All right, so now I'm going to go to my calculator and put that augmented matrix in. All right. Okay, so I'm going to go to my matrix menu. Second inverse gets me to my matrix menu, and you can see that I have 7 different matrices in my calculator. I have matrices A through G. I'm going to go delete those. I'm going to start fresh. So to delete a matrix, first get out of your matrix menu, second quit, and you're going to go to your memory, which is above the plus sign. Then we're going to do memory management delete, which is number 2. I'm going to go down to number 5, matrix, and I'm going to delete those using the delete key. Delete, 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 delete. All right, so now I'm ready to go put that augmented matrix in my calculator. Second matrix, and I'm going to arrow over to edit. And I'm going to put that first augmented matrix in matrix A. So when I hit enter, my calculator needs to know how many rows are in my augmented matrix. This is a 3 by 3 system, 3 equations, 3 variables. So there are 3 rows because there are 3 equations. And I hit enter. And then I need to tell my calculator how many columns I have. Well, I have 4 columns. So I'm going to put that in. It's a 3 by 4 matrix. And then you just input the numbers into the rows. So you put a number in, you hit enter, you put a number in, you hit enter. So my first row was 4, 4, 16, and 12. Then it drops me to the second row. I hit 4, 3, 12, and 9. Drops me to the third row. 4, 6, 33, and 9. I'm going to do a quick check to make sure that I've inputted that correctly. 4, 4, 4, 4, 3, 6, 16, 12, 33, 12, 9, 9. So I am good to go. Now to perform row operations on this matrix using my calculator, I need to exit from my matrix menu and then go back in. So I'm going to do a second mode to quit. Then I go back in, second matrix, and I'm going, oh, you can see the matrix is there now that I've inputted it. I've got a 3 by 4 matrix in matrix A. I'm going to arrow to the right to the math menu. And I'm going to arrow through this menu until I find RREF, and that's going to be B. And RREF is reduced row echelon form. And that is using Gauss-Jordan to put my augmented matrix into reduced row echelon form. So I'm going to hit enter. And then I have to tell my calculator what matrix am I doing row operations on. It's matrix A. So I have to go back to my matrix menu one more time and tell it A. So I just hit enter, close my parentheses. That's a really good habit to be in, and then hit enter. So what we have here is the reduced row echelon form matrix. And what's great about this is that the fourth column is our solution. So x is 0, y is 7, and z is -1. Now I'm going to write that on my paper that I'm going to turn in, that this is my reduced row echelon form matrix. So stop sharing here. Okay, so I'm going to put that matrix on my piece of paper. So it was 1, 0, 0, 0, 0, 1, 0, 7, 0, 0, 1, -1. So if my matrix is now in reduced row echelon form, the last column is my solution. So x is 0, y is 7, and z is -1. And I can do a quick check of this to make sure that I've inputted everything incorrectly. So I can just do this in my head, hopefully pretty quick. 28 minus 16 is 12. That works in the first. 21 minus 12 is 9. It works in the second. 42 minus 33 is 9. It works in the third. All right, let's do this again. That was so much fun. Let's do Gauss-Jordan elimination. Again, I understand the instructions say Gaussian. There's no reason why I can't use Gauss-Jordan. Okay, so let's write the augmented matrix. 9, 29, 6, 16, 4, 13, 5, -6, 1, 3, -4, 6. Okay, I'm going to check that real quick. 9, 4, 1, 29, 13, 3, 6, 5, -4, 16, -6, 6. Okay, so now I'm going to put this in my calculator, and I'm going to put this in matrix B. As a matter of fact, I typically write on my paper where I put it, and that way I can keep track of where it's at. Okay, so I'm going to share my calculator. All right, so I'm going to put that 3 by 4 matrix in matrix B. So go to second matrix, go to edit, and go to B. It's going to be a 3 by 4 again. 3, enter, 4, enter. And then we're going to put in the elements by row. So 9, 29, 6, 16, 6, enter, 16, enter. And then the second row, 4, 13, 13. And if I make a mistake, there's no reason why I can't use my arrows on my calculator to move through the matrix, find my mistake and correct it. 5, and then -6. And then the last row is 1, 3, -4, and 6. All right, so let me check this. 9, 4, 1, 29, 13, 3, 6, -5, -4, 6, 5, -4, 16, -6, 6. Okay, so we're good to go. So I'm going to get out of here. I'm going to go back into my matrix menu, go to the math menu, and I'm going to arrow up to reduce row echelon form, and I'm going to conduct row operations on matrix B. Okay, I have a problem. And the problem is in that, well, there's a couple of problems. First of all, this is not reduced row echelon form. See the matrix above me, above this one, where you have the main diagonal are all ones and everything else except that fourth column is zeros. Look at this first row here. I have got a -16, a 67, excuse me, where I should have a 0. and I have a 21 where I should have a 0. And look at that last row. The last row says that 0x plus 0y plus 0z is equal to 1. It is saying, remember that vertical line there represents equals. It's saying that 0 is equal to 1. That is not true. So what we have here is we have a system of equations that doesn't have a solution. Because that third row, if the third row, the first three elements are 0, and the fourth element is a number other than 0, that means that system does not have a solution. So I'm going to write that matrix down on my piece of paper. I get 1, 0, 0, 0, 0. I'm writing it by columns. 67, 21, 0, 0, 0, 1. Okay. Let me stop sharing of my calculator so we can see my paper. So that third row says that 0 is equal to 1. That is not true. There is no solution to this system of equation. So part C. Okay, use Gaussian elimination. Again, Gauss-Jordan is fine. So let's write the matrix. Now I'm going to put this in C. I have all those matrices available to me. I might as well use them. Okay, so what do we have here? 6, 4, 2, 0, 3, -3, -5, -1, 1, 1, -1, 7. Let me do a quick check of that. 6, 3, 1, 4, -3, 1, 2, -5, -1, 0, -1, 7. All right, so I'm going to go put that in my calculator. Share my calculator so that we can see it. Okay, so I'm going to go to my matrix menu. I am going to edit matrix C, number 3 there, and that is going to be again a 3 by 4, 3 rows, 4 columns. And let's put that in. So I have 6, 6, try that again, 6, 4, 2, 0. Oops, put the 0 in there. There we go. Second row is 3, -3, -5, and -1. And the last row is 1, 1, -1, and 7. All right, so let's do a quick check. 6, 3, 1, 4, -3, 1, 2, -5, -1, 0, -1, 7. All right, so we are good to go. Let me get out of there. Let me go back in my matrix menu. I'm going to go to math. I'm going to find RREF. And I'm going to conduct row operations on matrix C. So go back to my matrix menu and pick C. Okay, so this is reduced row echelon form, so we are good to go. So the fourth column is my solution. X is -2, Y is 5, and Z is -4. So I'm going to write that down so we can see it when I stop sharing my calculator. Okay. Okay, so it looks like the solution is, there's one solution, so it looks like -2, 5, and -4. And I would probably do a quick check on that. Just do it in my head. So I got -12 plus 20 is 8. 8 minus 8 is 0. So it works in the top equation. I have -6 minus 15 is -21. -21 plus 20 is -1. It works in the second equation. Then I have -2 plus 5 is 3. 3 minus a minus 4 is 7. So that is the solution of that system of equations. All right, finding determinants. To find a 2 by 2 determinant, you're going to use the formula that we give you. You could use your calculator. I don't know that it's necessary. To find a 2 by 2 determinant, you multiply the main diagonal, A times D, and you subtract from it the other diagonal, which is B times C. You always subtract, so you multiply first this diagonal, and then you always subtract the other, and it's always a subtraction. This is always a subtraction, always. Okay, so what are we going to do? We're going to take 5 times 7, and we're going to subtract from it. We're going to subtract 7 times 7. So 35 minus 49, I believe that's -14. All right, use Cramer's rule for the next two problems. I don't care if you don't use Cramer's rule. Looking at that first system of equations, problem 17, I could just add those two together. X is 2. And y would be what? 5 times 2 minus 3y is 4. 10 minus 3y is 4. -3y is -6. Y is 2. So I could do that in a matter of seconds, not using Cramer's rule, just using addition. But let's go ahead and review Cramer's rule. Okay, I need to find 3 matrices to solve a system of equations using Cramer's rule. The first matrix I have to find, so we're doing problem 17 here, is this matrix determinant called D. And it's the determinant of the matrix formed by the coefficients on x and y. So you just remove the x's and y's and put the coefficients in. 5, -3, 7, 3. Okay, so that's going to be 5 times 3 minus, and you're going to multiply -3 times 7. So it's going to be 15 plus 21, which is 36. Okay, the second matrix you're going to find is this matrix we call D sub x. And we're going to find that matrix, that determinant of that matrix, by replacing the x column, that is that first column, with the constants. So we're going to put in 4 and 20, and then we're going to leave the y column the same, and the determinant would be 4 times 3 minus a -3 times 20. Really be careful when you're doing this with the signs. So that's going to be 12 plus 60 is 72. All right, the next determinant we're going to find is D sub y. And D sub y, we take the determinant D and replace the y column with the constants. So the first column is the same as the x column in D, but the second column we replace with the constants. So that's going to be 5 times 20 minus 4 times 7. So that's 100 minus 28, which is 72. So now what's x and y? X is D sub x over D, which is 72 over 36, which is 2. And y is D sub y over D, which is 72 over 36, which is 2, which is exactly what I got using a quick addition. If I just quickly add those two equations together, I get the ordered pair 2, 2. Now, problem 18 is probably not quite so easy just to solve using addition. I certainly could use Gauss-Jordan elimination on that. That would work brilliantly. But let's do Cramer's rule just for fun. Okay, so this is problem 18, the last problem on the test. Okay, so I'm going to create my determinants. I have 4 determinants that I must find to be able to solve this using Cramer's rule. The first determinant D, which is created from the matrix that consists of the coefficients. So D is equal to, and what did I have here? I have X minus Z. So I have 1, 0, minus 1. The Y coefficient is 0 in that first equation. In the second equation, the X coefficient is 0, Y is 4, and Z was -1, the coefficients. And in that last equation, the coefficient on X is 3, the coefficient on Y is 0, 5, and the coefficient on Z is 0. And one of the reasons why we give you something this easy is that if you were finding the determinant by hand, this is a very easy determinant to determine by hand. I'm going to use my calculator. Okay, now we're going to determine the determinant, d sub x. So we're going to replace the first column, the x column, with the constants. And the other two are the same. D sub y, let's write that up here. D sub y, we're going to take d and replace the second column with the constants. The x column and the z column remain the same. For d sub z, we take d, the first two columns are the same, and then we replace the z column with the constants. And I'm going to do a quick check to make sure I have these all written down correctly before I go and start putting these in my calculator. So the first determinant should be 1, 0, 3, 0, 4, 5, -1, -1, 0. Check. The second determinant should be -1, 20, 22, 0, 4, 5, -1, -1, 0. Check. D sub y should be 1, 0, 3, 0, -1, 20, 22, correct. -1, -1, 0. So that looks good. And d sub z should be 1, 0, 3, 0, 4, 5, and -1, 20, 22. So I think I'm good to go put these in my calculator. So I'm going to put all 4 of these in my calculator and let my calculator calculate the determinant for me. Like I said, it's pretty easy to do by hand. Um, I'm just not going to. All right, share my calculator. So I'm going to put each of these matrices in a matrices that I haven't used already. So I'm going to put D in E. I'm going to put D sub X in F, D sub Y in G, and D sub Z in H. I might as well use up, I've got all those matrices to use. I might as well use them. And if I don't replace it, delete a matrix and replace it, that helps me a whole lot by checking my work later, because I can always recall a matrix. For example, if I want to know what A looks like, I could certainly go to my matrix menu and then edit A so that I can see what it looks like. I could do that. I can also just go into my home screen and recall A. So just go in there to the names, hit A, hit enter, and it'll tell me what matrix A is. So I don't really want to delete those until I'm completely done with my exam. All right, so let's input that first matrix. So now I'm going to put D in D. I think I said I was going to put it in E. Let's go ahead and put it in D. That's since I have D available. I wasn't kind of paying attention to what I was doing there. Okay, so we're going to put that in D. We're going to put that in E. Put that in F. Sorry, I'm writing on my paper over here. You can't see me. I'm going to put that one in G. Make sure I know where I'm putting everything. All right. So now I'm going to be putting in a 3x3 matrix, because to find the determinant, you can only find the determinant of what is called a square matrix, where it has the same number of rows and columns. So you're not creating an augmented matrix. You're creating a square matrix that you can find the determinant of. So we're going to do that 3x3 first. D. So I have 1, 0, -1. 1, enter, 0, enter, -1, enter. Then we're going to put in 0, 4, -1, and then 3, 5, 0. Okay, I'm doing a quick check. 1, 0, 3, 0, 4, 5, -1, -1, 0. Okay, so I've got the first matrix in, so I can find the determinant D. Now I'm going to put the second one in. So I exited out of the matrix menu. I'm going to go back in. I'm going to go over and I'm going to edit number 5. It's going to be a 3x3. And now I'm going to replace that first column in D with the constants. So my first constant was -1. And then we're going to put in the other two columns, 0, -1. 20 was the constant in the second equation. 4 is the coefficient on y. -1 was the coefficient on z. 22 was the constant in the third equation. The coefficient on y was 5. The coefficient on z was 0. Okay, I'm going to do a quick check. -1, 20, 22, 0, 4, 5, -1, -1, 0. All right, that one's good to go. So we're going to get out of here. Now we're going to go back in. We're going to edit number 6F. It's a 3x3, 3 enter, 3 enter. Okay, so we're going to put in D sub y. The first element was 1. Then we're going to put in the first constant. The first constant in that, with a constant in the first equation was -1, and z was -1. The coefficient on z was -1. All right, so we're going to put in the second column, 0, second row, excuse me. 20 was the second constant. And then we're going to put in the coefficient on z, -1. Okay, the coefficient on x was 3. The third constant was 22. And the coefficient on z was 0. Okay, I'm going to do a quick check. 1, 0, 3, a -1, 20, 22, -1, -1, 0. So we're good to go there. Now the last one. Go back into our matrix menu. We're going to edit number G. Matrix G. It's a 3x3, 3 enter, 3 enter. And then put in the matrix. 1, 0, -1, 0, 4, 20, and then 3, 5, 22. And do a quick check. 1, 0, 3, 0, 4, 5, -1, 20, 28. Okay, so we have all the matrices in there. Now we're going to go find all the determinants. So we're going to go back into our matrix menu. And we're going to go over to math. And number 1 is determinant. DET open parentheses. We're going to find the determinant of all 4 of those matrices. So I hit enter. That brings the DET back to my home screen, and then I tell it what matrix I want to find the determinant of. So I put that first determinant in matrix D. So I'm going to go second matrix D, number 4. And I'm going to find the determinant of matrix D. That's going to be 17. So I'm going to go write that on my piece of paper, 17. Now I'm going to find a determinant of E. So go into my matrix menu, go to the math menu. Number 1, I'm going to find the determinant of D, go back into my matrix menu. I said D, E, number 5. So at least I'm in alphabetical order. I found D, now I'm going to find E. And that is negative 17. So I'm going to write that down. And then we're going to find the determinant of F. So go back into our matrix menu, go to the math menu. Determinant is number 1. We're going to find the determinant of F. Go back into the matrix menu. F is number 6. That is 85. So I'm going to write that down. And then last but not least, the determinant of matrix G. So we go back to our matrix menu, go to math. Number 1 is determinant. I'm going to find the determinant of G. And I get 0. Well, that's good. All right. So now let's go back to my piece of paper. So I wrote all these determinants down, what the value is. Now to find x, y, and z. So x is d sub x divided by d, which was negative 17 over 17 is negative 1. Y is d sub y divided by d. D sub y was 85. 85 divided by 17 is 5. Z is d sub z over d, which was 0 over 17, which is 0. So my solution is negative 150. Let's write that up here. Negative 1, 5, and 0. And let's do a quick check. So I have negative 1 minus 0 is negative 1, so it works there. I have 20 minus 0 is 20, works on the second one. I have negative 3 plus 25. Negative 3 plus 25 is 22. So it works in the last equation. So it looks like I have all my systems of equations solved correctly.